Hey, let me fix that. Perfect. How are you? Welcome to this Global Hack Week, Generative AI Week. So, first of all, thank you so much for joining, and let me introduce myself because I always forget to do this. My name is Alberto. I'm your majorly hacking coach from Mexico. So, I am so honored to be your host this evening, or well, it depends which time zones you are in, right? So we have a nice comment here from Quakers and Cheese. So I remember you were on part one. That's amazing. So hey Quakers. So I know it's up to all of the coaches differently if they how they manage their streams, but I really like to have my comment sections always at this side of me. So um, at any time, please just post a comment if you have any question, if you just want to share a great resource or something. I'll be on top of that during all stream, right? So let's start with this because we had a lot to cover, right? And also, I have another stream coming up, which will be Rack 101. So probably we'll be ending this a little bit sooner, like 15 or 20 minutes earlier. So we have time also to prepare for the next one, right? Um, well, that'll be it. Thank you. Let me start sharing now my screen. This is how to set up your local Gen AI part 2. If you missed the chance to join us on part 1, don't worry. You can always find the recording in the YouTube channel. Or if you head to Global Hack Week, ghw.nlh.io, I'll share the link here really quick. Just give me a second. Uh, uh, um, mlh.eu. Perfect. Well, you will have a chance to watch the recording for that, right? And I really encourage you because, yes, we are going to do a really quick recap, but there's a lot of information in that stream, right? Also, before I forgot, because again, I always miss this. Oh, yeah, you're right. Typo. It's AMLH, not HLH. Give me a second for that. Yeah, that's perfect. Thank you. Um, and yes, please check into this event so you can win your community points, right? And that's it. So let's do that recap. Let me open the slides for that. And I have them here. Copy path. And let's open a new tab. Perfect. The ones for the part one are also in the repository for this session. They are the same as the previous one. So to set up your local GenAI part one, uh, we cover what long language models are, how they work. In simple terms, of course, this was not um, explanation in depth, but yeah, I think it's worth it to check it out that again, right? Um, Then we check the introduction to Olama, that it's long language model runner, so it helps manage everything we need to run this locally. And then we pull, well, how to install it, alternatives and stuff, and then a practical guide on how to use it, right? We install Olama, then we pull a model from the repository, and I did make the suggestion that Olama is like the Docker, but for long language models, right? And I think that's still very accurate. Uh, if that means something to you, and if you are a user of Docker. And all I'm run Gemma 3.1 billion parameters because this was like this model we call run. Today we're going to use the same for everything, and at some point we are going to try the multimodal one, so that will be the 4 billion parameter. Don't worry, it's I think 3.3 gigabytes of memory, so I think we can handle that. Um, then we test the API integration that has Olama to offer us so we can interact directly with the curl command. This previous one helped us interact via the bash, but we also create a script in Python to get access via the API. And finally, the last thing we did was build a beautiful Streamlit app that help us manage some chatting with the actual um, model, right? And that will be it. Remember, you can watch these on the recordings, but right now we're in part two. So I promise you, we're going to integrate these self-hosted UI. That's an open source project called Open Web UI. That will be really quick, real simple, but you will see the huge difference from doing something uh, from ourselves, like the Streamlib app we created, and this that it's open source, and I think it's amazing, and it's really really huge, and it's also very recommended by the community. And if you want to make improvements, of course, it's open source, so go ahead and do it. Then we're going to implement this with Visual Studio Code, and I I'm planning to do a production service with microservice and Docker. But there's another thing I would like to do. And the way I was preparing this, um, I discovered there was a way we could fine tune without actually retraining the model. I will explain that deeper, but that will be a little experiment I would like to do also because of time and so. But yeah, I think that would be really, really interesting if we could manage to do it. If not, okay, don't worry. I did promise you these three things, and we're going to do them. The other, it's just for fun for us to explore, right? Let me see. Have to sleep. First person was nice. I'll catch the recording later. Yeah, don't worry. Of course, I will always recommend that you have a really nice time of sleep. Um, we need to sleep to learn. Actually, there's people that says I don't need to sleep. I just need to study, or I'll be here. Don't worry. Go have a good rest and then come back. There's always the recordings, right? Good idea. Have a good night. Yeah, actually, I agree with that. So. Um, Sorry, I received an important message. Okay, perfect. I'll silence this. Now, let's return to the previous slides and the part two. Perfect. Let's start this. The ideas I give you, spinning up with Open Web UI, the integration with VS Code, and then this part, I think it's going to be really time consuming for us, but also again really really interesting to explore, which is the fine tune with the LoRa and PEFT. What's that? Let me remember the meaning. Um, that's state of the art parameter efficient fine tuning methods. And there's a library, of course, from our Hugging Face friends that can help us do that. So, again, that will be kind of experimental because I haven't done that, but I think will be worth exploring. Then we are going to play with the multimodal models, and finally do the deploy with the microservice. But of course, I put that fine tune in the third step because I think that will be extremely useful and for the future hackers you're interacting with or you're enrolled to do that fine tune to your data and then deploy to a microservice or a service that you can consume. Right, that will be amazing. That will be insane. So let's start doing that. The first thing, as promised, it's setting up Open Web UI with Docker. If you haven't done it or you don't know what Docker is, there's this concept about containers that help us as software developers to make sure everything is standardized, right? So in simple terms, the containers are in the real world like these huge metal boxes. They can store a lot of things. And why we call these containers in software? Because they are the same. The containers in real world solve the problem of uh, if some companies had to ship something, then they didn't have standards for the shipment boxes. So the people that need to ship that, the ones in the boats, had the solution of saying, okay, everything needs to fit in these containers. So containers have always the same dimensions, the same structure. They're standardized. So containers, it's just a way to standardize something, right? Keep it that. Now, in code, we probably heard often, hey, that worked on my computer, but now it's not working on yours. I swear, it worked on my computer. Containers solve that. And Docker is just one way to do containers. There are other that's Kubernetes, or how do you want to pronounce it? Um, but yeah, let's do Docker. And here, having the image of in Docker means we can like pull a repository and we'll have something running really quick, and you will see. So once we have an image, we're going to create a container based on that image. And in resume, we do a command that it's Docker. We are indicating the bash we are going to run at Docker command. Run in detach mode, which is the the flag D, in the port from the 300 to the image 8080. So we are going to use our computer 300, sorry, 3000. The version that has the web UI authorization failed because uh, either way you will have to authorize. You will see what I'm talking about. I mean, like try to it without the web UI at false, and you will see the difference. Then open the web UI. That's how we are going to create call our image, and how we are going to. Sorry, the name it's how we are going to call the container. Sorry, and then that we are going to create or make use of our Olama integration with this, right? So I know that wasn't a great explanation on how Docker works. It was a really quick one, but I think it's worth mentioning for someone that doesn't know actually Docker yet. If you do know Docker and you think I say something wrong or I could say it better, hey, please correct me here in comments. And for that is why I was using the metaphor of Olama, because with Olama it's kind of the same. We pull a long language model from the server, we create that in our local machine, and Olama manage everything for us to get it run. We have a comment from 404 not found. Hello, hey. So how are you? Nice to have you here. Well, let's try this on our machines. Actually, when you install Docker, you will have something called the Docker Hub. I will show you my Docker Hub. For example, here, my Docker Hub right now looks like this. I'll try to see if I can make it bigger. So this is just a visual way we can manage was or on or Docker, right? We can also do this directly on the terminal, but hey, for I know there are people who just hate UI interfaces, but for some people, this can be like more um, easy to process, right? So here we have two containers. I'm doing a project which is for EMQX. Actually, this is MQTT broker. If I can manage to show you this will be for the next Global Hack Week. That will be season launch, and I will be showing you my thesis project. So I'll leave a spoiler on that. Oh, I see a lot of comments popping here. Um, Missing pizza, but excited for the stream. Hey, thank you. Pizza sounds good. Yeah, actually, I'm kind of getting hungry here. Pizza always sounds good. Also, nice to see you here, Gregor. I was 90% sure you only spine when pineapple is mentioned. So, actually, I do like pineapple in pizza. I know that's controversial, but I think it takes all the flavor. Like pineapple, it has a strong flavor. I do like pineapple. I enjoy it in like other dishes, uh, but not in pizza. I just think it's too protagonizing. I don't know. Like I like to enjoy other flavors, and when pineapple is added, it's just pineapple flavor. You're a liar, Roberto. Yes. Hmm. So let's continue. Um, so this is my Docker right now. I have many images, some of the work, some, well, many of for work, some of for fun, and so on. Right now, I have this running, but hey, I'm going to stop it. And for you, since it's the first time, you are going to copy and paste this same command, which was run. So for running this, Docker creates a container based on an image. If it doesn't find the image, which is this one, this last one, ghcr.io slash openweb, blah, blah, blah. If it doesn't find it, it will pull it and it will store it. That's perfect. Uh, the name of our container will be Open Web UI. So for you, it's going to be run. For me, I just need to start it because I already have it. And you see, I stop it. So I have Docker. This is the command for you. Docker start Open Web UI. And I have it started. In the visual interface, I can see this is running and I have this green button here. But also in Docker, you can just always say PS, and I'm sure this is now running, right? Perfect. So once we have this running, we could head directly to our web browser and search for localhost 3000. And this is going to be loading. And now we have our UI, or beautiful UI for interacting with our local model that, remember, it's Hemo3. How we are sure about that? Well, we can always say the same. Oh, right now we don't have this running, so I'm run Hemo3 and exit. Okay, we have it running now. Yeah, Hemo3, it's or predefined right now. We can always change to another one. I also had test with DeepSeek, but we can always try local and well for a more uh, extents list, we probably need to pull it from Olama, right? But you can see this is actually very, very similar to what ChatGPT is currently, right? So we can say something like, why this cat is blue. And we see a really nice output. And we have our chat here stored. And also, we have a history of chats. This is for today, right? So once we finish this, we can start a new one. And well, we can do things like give a thumbs up to the response, speak it, copy it, modify it, regenerate it, and other implementations like go on. I think you were interrupted because remember the context window here for our local models it can be something, and we ask if we ask for something really really huge, we probably need to apply these techniques of splitting it. Remember when in if you asked for ChatGPT something very large, it got interrupted at the middle because you run out of tokens now, and then you say or you have to hit something like, "Okay, I think you got interrupted here. Um, continue," or it would just mean. I'm pretty sure we can discuss about many ways we do when interacting with ChatGPT, right? But well, for doing that, we just can say hit the button to continue response. I think that's interesting because all of this is generated in English, but I see now like the suggestions here are in Spanish. I think that will be because of my browser settings. I don't know. Yeah, controles instead of controls. Yeah, all of this is in Spanish, but well, I can translate. Don't worry. Well, let's start a new chat then. And in this one, for example, this was called Ray Light Scattering Explain. Right now, I can ask something like, "Hey, I just deployed this open web UI via Docker." Let's see what Hema responds. "That's fantastic deploying Open Web UI via Docker. It's a great move. Congratulations. To help you the best, I little need more information. Let's break down this into a few areas. What specifically are you hoping to do now? What's your current setup? What's the specific issue you're encountering?" Okay, like it wants to know what I can help you with, right? Basically. So we can say something. Uh, I just wanted to. Well, no. Let's ask actually for something. Oh, what's the main thing you're trying to achieve? Can you walk me through the steps? How can I customize it? That will be interesting to mention. Let's dive into customizing Open Web UI. Here's a breakdown of the areas and ways to customize it. Configuration files, key customization points, and how to modify the dashboard, UI themes, web interface, and a lot more. Um, hmm. Happy configuration if you're using API, just the API URL. Perfect. So here we can see the menu, the model we're using. Here on controls, what do we see? Tools, functions, advanced parameters, talking. Okay, keep alive. All these from Olama. Prompt. Okay, so something that can be interesting is that, for example, these are following questions we can do. So we have this suggestion if we run out of ideas of what to ask, or we if actually we did not understand the previous explanation. So these are like these following up questions. um, was part one recorded? Of course, actually. So you can head to the Mainly Hacking YouTube channel and you can see the recording there. Also to globalhackweek.mlh.io and you can see there the link for the YouTube channel. So yeah, I was just thinking of another thing. Here, okay, thanks. But is there place to store these files? I can't see the code base. Remember, I wrote this from Docker. Yeah, I'm missing that. Run it. Run. I set this from Docker. Let's see. Hey, thank you, Quakers, for sharing the YouTube channel for the recording. Here it is, everyone. It's interesting. https://youtube.com/@hacking/streams. So thank you so much. So here, yeah, you're absolutely correct. I could apologize for the oversight. You're right to ask about storing the configuration files. It's a very important consideration. There is a place to store the configuration files. Path to your open web UI. So if you deploy the containers in directory, blah blah blah. So we probably need to do a project where we're using a local system and then deploy it on Docker. Right now, we're just trying a test image, so that's perfectly valid. So that will be this first part of exploring the open web UI part. Let's move to another one because yeah, this is great. All right, but um, only if you are on tired for asking something to ChatGPT in general terms. But again, we will discuss more about the advantages of doing this locally instead of using the free services online, right? Because ChatGPT is free. It has a free tier. Um, that probably has a much more powerful model. Not, I mean, not probably, for sure. That the one we're using here. Cons and pros. We can discuss that in the session. But one thing for sure, you probably are expecting it's okay. Again, in the past, we used to come here to these chat interfaces, paste our code, then expect the generated output if it was formatted in a readable way or something that we can show. Like, for example, here, I'm going to start a new conversation and hey, give me a or how to say, snippet of uh, Python code. Oh, how is spelled it? Small uh, piece of Python code. And for example, here it's format, so we can copy this directly, execute it, or do many other things, right? Uh, which is nice. Thanks, OpenWave UI. But probably if we are developing, we didn't want to mass time copying these, going to, or um, how to say this, to our Visual Studio Code, sorry, and then paste it and run it and so on, right? So fortunately, there's an alternative for that, which is running directly our model here in Visual Studio. Could you zoom? Yeah, yeah, sure. Here in Visual Studio. So for doing that, there's an extension. I mean, probably there are many. I have to be really honest. Probably there are many, but the one that's more recommended for the community of Alana, the first appearing, it's called. Um, oh my God! Let's return to the slides. I forget the name. Yeah, continue extension. So if you go to the slides, actually there's the link for the marketplace side of this Visual Studio Marketplace. Continue open source AI code assistance, blah blah blah. I'm going to return to the slides, but yeah, here we can directly on the extensions go on, right, continue, and this is the one this is the first to appear. Continue open source AI code assistance. Be sure that's the continue.dev one. Install it, and I had it disabled because it has conflicts with Copilot, right? So the thing is, you could use Copilot if you're a student or if you're willing to pay these $10 a month, which I totally think it's worth it. I don't pay it because I'm still a student. I love Copilot and I have a lot of great things to say about it. Actually, for example, here in my normal day-to-day workflow, I had this chat, so I just need to change the model I want, Gemini 5 Pro, Cloud Sonnet, the GPT ones, a lot of great models and very powerful. But hey, let's say, um, I think even Copilot has a free tire right now. But hey, let's say, uh, you can manage to pay Copilot. You can't manage to pay Copilot, or you're not longer a student. A great alternative is to run your model locally, or well, this is where it gets complicated because also if you're looking for security, but for really huge security, this does not connect to any server, so this does not share any software that you are sharing or sensitive data or so on or stuff like that. Um, so there are many alternatives and very valid for you to run this locally. And you need to install it. I'm going to enable it for the moment. I'm going to restart my Visual Studio. I'm going to code local. And when I open it, I see now here I have the continue extension. And for me, it's already configured, but you probably will be asked for either log in and use the online services, and that it's of course another option. But I think the point of having this extension is to run locally. So at the very bottom in small words, you will see the tried locally, and that's what you want to do. Now here, for example, I can ask local. We can create a new assistant. Uh, it asked us for go to online, but yeah, the local assistant is the one you want. you have to ask. In the configurations, uh, um, the prompts, the MCPs. We will are going to talk about MCPs, but that's a session for tomorrow. But yeah, documentations, rules, the models. Yeah, here, for example, same. I had DeepSeek, I have Hema, and here by default there is another one that it's Llama because this recommended for the chat one, but I changed it to Hema, and also Quintet 5 because it's the recommendation for autocomplete. Actually, there's no other option that I currently have, but we can be changing this with the time, right? Hmm. So we can select our model. We can select if we want to chat, if we want to do an agent. This is not supported for local or for next mode, right? So let's say we are going to ask a lot of things. Whew. Hey, help me create a code to find, sort, I don't know, what else? To sort, to make an microservice to run a local model. Right. Okay, let's outline the steps and provide a basic code structure for creating a simple local LLM service. This will be a simplified example. I'm focusing on Flask API. For the core functionality, I'll break it down into manageable parts, explain the reason, and provide placeholders for you to fill in. Important, this is a starting point. You will need to adapt it uh, to install dependencies like Flash, Recurse, blah blah, adapted to your specified model. Conceptual outline, model loading, API input handling, LLM call, response formatting, and so on, so on, and so on. Right? Explanation and key sections from Flask. Well, the code is here. The get LLM response. We define a route with the function generate. It tries to request the data prompt. If not prompt, error, missing a prompt, and the response of that. Right? We can create that and we can run it. And well, I think it's very huge and great structure response for a local model with only 1 billion parameters. I think that's insane. I mean, this is great. This is great. What do you think? Do you like it? You don't? Well, it depends again on your implementations. So let's create a new one. I just want to show you that this actually can hold. So um, create a hello world Python. So we can apply the code. Oh well, we can copy the code or we can insert the code. So we are going to create a new file called test. I don't know. Delete later. Py, and we are going to insert this. And if we run it, actually I had a virtual environment here, so source and py test delete layer. We had the hello world. So simple as that. Perfect. Actually, another thing I need to add now. I was forgetting this. That git ignore. So this comes perfectly handy because I can say create the git ignore content for an Python app, and it starts creating everything necessary. And I can apply this, and I just say is that correct also if I have a virtual environment folder in the project in slash them. And we apply this also. We had this, 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 and we were missing the BAMs, right? So here git status. Yeah, that's perfect. So let's continue with this. And I show you already how to use continue. I think it's great. It has advantages and so on. But I'm lucky enough to have Copilot, so I'm going to be switching back to it. So let me go to continue. I'm going to disable, and I'm going to restart the extensions. Great. So we can now return here. And close these also and delete the delete later.py. Actually, I don't think this is I don't think this is accurate because we are ignoring the Python files. Okay, I'll create this with Copilot. Add ignore for Python project. Yeah, that much better. Actually, this is huge. This is immense. This is more data we actually wanted. But the Picochet and the now see extension, the distribution packaging is the one it had me worried. No need for installers or logs or unit testing or translations or Django stuff. Maybe the Flask one. Um Scrapey Eater, not Stinks, or Pile Beetle, or Jupyter Notebooks, or yeah, this by M. Yes, according to blah blah blah, have packages. Well, I think we already have that, but don't worry. Amazon brutal lamps. Yes, perfect. All environments, no spider, no Mox, no MiFi, no this. Maybe the Visual Studio, but yeah, perfect. And that's for Kirito. And git status, yeah, this makes more sense. Delete me, please. Well, we're going to delete it. And yeah, that's great. Let's continue. Um, the third part, and one that's really cool and funny, we're going to start fine tuning all LoRa and PFT. Uh, for me, I come for another background of engineering, so the first time I hear this LoRa, I thought of another thing that's protocol for communication, as in LoRaWAN, which is for IoT and great bandwidth communication in small energy consumption. But here specifically in the context of LLMs, this stands for, give me a second, I have it around here, low rank adaptation, which is a parameter efficient fine tuning technique for the large language networks, long language models, that lets you adapt a huge base model to a new task. So that's what we are aiming for, right? So here we are going to make a small pause. I need to get more water. So let's take this small break. It will be 3 minutes or less, and I'll be back with you in a couple of seconds. In the meantime, if you're following, you have this time to get at the point we are now to test the Open Web UI, to test the Visual Studio integration. And if you have any question, please let me know here in comments. I'll be back in a matter of minutes. Hey, so I'm back. Great. With all the energies, I see there is no questions or comments or anything, okay, let's resume. Mm. Fine tune with Laura PAFT. Um, let's open the Hugging page, Hugging Face, sorry, page for this. So this is the PEFT repo, which is for parameter efficient fine tuning methods. Let me make this bigger. Give me a second so you can read with me. Um, and return this here. Great. Uh-huh. So let's first understand all these libraries we need to install and what they are for, right? So first, let's install the PEFT. Um, so here, let's start reading about this. Give me a second. Uh, 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 uh. Yeah. So, fine tuning large pre-trained models is often prohibited and costly due to their scale. Here, for example, we're talking just for this smaller model, 1 billion parameters. So, parameter efficient fine tuning (PEFT) methods enable efficient adaptation of large pre-trained models of various downstream applications by only fine-tuning a small number of extra, and this is important, model parameters instead of all the model's parameters. And I think this is very important because previous session we were discussing about uh, what fine tune is, because I talked about actually retraining the model or moving the values of the weights in the network. But here we well, not just here, but also we were talking about not only moving the existing ones, but adding more extra layers or adding like adapters or tune around the existing parameters, right? So this confirms fine tune also refers for this. So that wasn't me. Um, sorry. Well, I genuinely had a question also, but here we confirm. So this significantly decreases the computational and storage costs. Recent state-of-the-art PEFT techniques achieve performance comparable to fully fine-tuned models, which is great because we are doing also the same, but very low energy and low computational cost. So PEFT it's integrated with transformers. Uh, Again, previous class, this class, we discussed what transformers were, which is the architecture for the backbone of LLMs, and this architecture was proposed by the team of Google in the Attention It's All You Need paper. Reference it's in the previous stream, uh, and it's reading that it's worth doing, right? So again, PFT is integrated with the transformers for easy model training and inference. Diffusers for conveniently managing different adapters and accelerate for disturbed training and interface for really big models. A tip: visit the PEFT organization to read about PEFT methods implemented in the library and to see notebooks demonstrating how to apply these methods to a variety of downstream tasks. Click the Watch Repos button on the organization page to be notified to newly improved notebooks. That's a great tip. So let's open that and let's start watching the notebooks. So, the recommendation was to see notebooks, right? So let's take a look to the notebooks. Uh, Casual language modeling, conditional generation, diffusion, feature extraction, image classification, quantization, sequence classification, semantic segmentation, token classification. Well, our first case is the one casual language modeling. So let's continue reading things, and then we can go back to the casual language modeling notebook. Check the PEFT adapters hyperreference section for a list of support PEFT methods and read the adapters, stuff prompts, and AI tree conceptual guides to learn more about how these methods works. So again, probably that's a great thing to do, but offline right now. Let's just focus all on what we are trying to do in a more um, pragmatic way. So we install PFT and prepare a model for training with PFT methods such as LoRa. So in general, PFT it's like the family of algorithms, and LoRa it's just one of these algorithms. It's the method, and again, it's the low. What? I always forget. Sorry, I'm trying to get used to this. Um, Let me see my notes. Low rank adaption. Yeah, sorry. Um, Long rank adaption by wrapping this model and PFT configuration with get PFT model from the big scene MT0 large model. You're only training 0.19% of the parameters, which, if you put consideration, that's still a huge number of parameters if we have a billion. Can't imagine for the full models, for example, of 626 and 27 billion parameters. So, uh, a normal workflow, for example, like this, it's to import auto model from SIG to SIG LM from the transformers library, which is another that we actually are importing here. Then accelerate. We will see in a moment that. But for transformers, we import this, and from PFT we get functions like the get PFT config, get PFT model, LoRa config, and task type. Right. So the model name or brand and the tokenizer, blah blah blah, the config, and this example was for what? Prepare the model, install training PFT. Okay, yes. So we set the configs and then we start applying this to the model. The auto model for SIG to SQL LM from pre-trained and the full model to get the PFT model and then print the trainable parameters. So the trainable parameters are just the 19%, dot 0.19% of the full parameters, right? Uh, so this is the interesting thing to have. To load the PFT model from an interface, we do this. Again, from the library imports the auto prefer model for casual LM. Then from the transformers, we import the out tokenizer. And finally, we are going to use Torch as our neural network library, artificial neural network library. Um, okay, let's continue. Why you should use this, blah, blah, blah. I think we are already convinced about why we should use this. But let's then return to the casual model training. Click to view an example collaboration notebooks, for example, interface with LoRa and accelerate. LoRa, just like that, prefix tuning and prompt tuning. Let's open the LoRa one, but also let's open the interface one. So the casual language modeling, this is training PFT models with new tokens being added to the embeddings layer and tokenizers. In this example, we will learn how to train a LoRa model when adding new tokens to the tokenizer model, and this common use case when doing the following: instruction fine tuning with new tokens being added, such as user, assistant, system property to format the conversations. Fine tuning on a specific language wherein the language specific tokens are added. For example, Korean tokens being added to the vocabulary for fine tuning the LLM on Korean datasets. Um, we can also do instruction fine tuning for return outputs in certain formats to enable agent behaviors such as functions, browse, text to image, ASR. I don't know what's that. TTS. I also don't know what's that. Generate code or racks, right? In such cases, you add the embeddings module to the LoRa target agents, and the PEFT will take care of serving the embedding layers with the new added tokens. So, thanks of God, we have this library. With the adapter weights that we are training on the specific initialization of the embedding weights of the added tokens. So, we need to import the necessary libraries for these OS environment if the CUDA is available, the environment, the transformers, a lot of functions for PFT, again, a lot of functions for the transformers, torch, data class field. So we need to prepare the model and the tokenizer, special tokens. We don't want special tokens. We'll be fine tuning Ministral 7 billion model parameter. So let's load the tokenizer and add special tokens followed by the base mode. Uh-huh. Then we apply LoRa. Then the model is these special tokens. Okay, I'm trying to understand also what the code here is doing. Oh my god, I'm sorry. Let me make this way bigger so you can read with me. Yeah, sorry about that. Um, yes, so this is the setup for the special tokens. We will be fine tuning the ministral, so the model name is this. Tokenizer, it's the auto tokenizer from prepaid model. The Okay, then we apply LoRa. Then what happened after we applying that? We prepare the datasets. From datasets, the library we imported load dataset. The dataset here it's in Smang rule as system chatbot dataset. The dataset we are going to split for training, the text column, the label, and then execute a training function. I'm guessing. Okay, yeah, train dataset. Okay, this is extends. This is not that beginner friendly. So let's take a look to this other one. Hey, hello, fellow hackers. Great to have you here, Concord. Concord of patches. Okay, so transformers here. Load CML Excel LoRa casual language modeling accelerate big model interface. So from the transformers, we import how to model for casual LM. From PFT, we import the PFT model, the PFT config. We import torch as well. Datasets from globe datasets from dataset, the OS function, operating system, transformers, the auto tokenizer, the data loader for torch util data, the default data collector, get linear schedule warm up from the transformers, TQDM from GT. I don't know what's TQDM. Um, and again, this is kind of imported twice. I don't know why, but we can flag that. Device CUDA, a model name or path, tokenizer name or path, That's a name, text column, label column, blah blah blah. Okay, so you can load your model from hub or local. Load model from Hugging Face, for example, or load model from local. PFT model, Twitter complaints, blah. Mhm. PFT model ID, model evaluate, test predictions. Okay, so let's return to this quantization. Okay, let's return to see the quick start PFT. Quantization, it's another method for reducing the memory requirements of a model by presenting data in a lower precision. It can be combined with PFT methods to make it even easier to train and load LLMs for inference. Save computed storage, PFT integrations. We also have diffusers, accelerate. Uh, Here, let's open Accelerate. Accelerate's library for distribute training and interface and various training setups and hardwares. So, oh, let's see. That enabled same PyTorch code to be run across any distributed configuration by adding just 4 lines of code. In short, training and interference at scale made simple, efficient, and adaptable. TRL. Oh, this is where they explain TRL. PFT can also be applied to training long language models with reinforced learning human feedback components such as the ranker and the policy. Okay. Why it's called TRL? Okay, well, I don't know. Model support, contribute, and citing. Um, okay, this is going to be interesting, quite challenging. I think I had something prepared for this. Yeah. So I have this prepared for the the session. Let's see if it still works. So we import the auto model for casual LM and the auto tokenizer, same as in the notebooks. The Lara config, the get PFT models, prepare the model for int 8 training, and load datasets. And again, from the transformers, I import the trainer and the trainer arguments. So we load the base model and the tokenizer. So we store the tokenizer without tokenizers from pre-trained, and we set the name of the model from pre-trained. Also, we get the base of the out model for casual LM uh, with the same the name of the model, load in 4-bit, and the mice. I didn't see they do this. I'm not sure where PFT model Lara config. So hmm, these were here or even here, right? Yeah, here the Lara config, but also the PFT config. Prepare. Okay, yeah, here prepare model for 8 in training and get PFT model, but I'm missing here either, well, both the PFT config and the PFT model. Let's see what they do now. Prepare the model and tokenizer. Special tokens. I don't want to have a class for special tokens. Uh-huh. The model name, the tokenizer, it goes from auto tokenizers, from pre-train, and here it's passing the model name and a lot of things more. Path token, boss token, EOS token, additional special tokens. I'm not sure we need them, so just model name is required. For that, let's check the auto tokenizer function in the transformers library. So let's open the transformers library. Accelerate. No, transform transformers. The movie Transformer Python. Here, machine learning, blah blah blah. Let's open repo. State of the art pre-trained models for interface and training. Installations. Pip install transformers. Pipeline. Why should you since use state of the art models? Low computer cost, choose right framework. Um, Customize model. Why shouldn't I use this library? It's not a model or toolbox or building blocks of neural nets. The code in the model files, it's not refactor. The trained API is optimized to work with PyTorch model. For generic machine learning loops, you should use another library like Accelerate. Actually, here in the code, we're not using Accelerate. Now I think of that. Um, my bad. Projects using transformers. I actually didn't have that much time to prepare this, so we're doing that in life. Um, 100 projects using transformers, example of codes, audio computer vision, NLP, citation. Ah, come on. I need more. Let me find the docs. Notes, building documentation, for example, note, blah, renaming section, source in English, and we are trying to get auto tokenizer. Let's test source transformers templates. Let's see here. Uh-huh. Auto tokenizer class. And we have the from pre-trained. save the pre-trained tokenizer locally, and you can reload its config from transformers. Import tokenizer from pre-trained Google Bird, blah blah blah. Huh. Boiler case. Pre-trained modeler path. Okay, this is a generic tokenizer class that will be instantiated as one of the tokenizer classes of the library when created with the method. These class cannot be instantiated directly using init. That throws an error. So we have the class pre-trained model name or path, inputs, and no args. So for the parents, the pretend model name or path, it's a string, can be either a string, the model ID of a pretend tokenizer host inside a model repo on huggingface.co. Path to a directory containing vocabulary files required by the tokenizer for instance saved using that. Uh, Path to or model inside repo. So probably I mean, probably Hema works here, Hema 3.1, but I'm not sure. So I'm guessing this will work. Now, from PFT, from the transformers, we have these two. We are missing the HF arguments parser, the training arguments, and the trainer, everything, basically. Well, no, yeah, the trainer and the trainer arguments, we have that. Um, okay, well, just these two are missing: the default data calculator and the HF argument parser. Configure LoRa. Here, LoRa was configured differently. If I remember, prepare model and tokenizer. The special token class, we don't need that. But we have our tokenizer and our model. We probably pass these two. Let's make these like this. So we have for sure we can comment this or uncomment this later. Then we resize token embeddings, but where you're applying the prepare for active model training. Apparently, just here. Okay, it's not used. Well, we're going to use it. So, loading checkpoints, chart embeddings. Then we apply LoRa. We set a LoRa config, and that LoRa config has R, LoRa alpha, LoRa dropout, target models, and that's saved in a config. We have that, and then we apply to get PFT model of the model we previously defined and the configs, and we save that in the new model. Then let's do that. Let's print the model and the trainable parameters just to make sure everything works. These far. and let's comment the rest. And let's run this. Let's see. Probably will take some time to run. So again, if you have any question in the meantime, don't hesitate to ask me. Don't worry. I now don't know everything. Okay, we have an error here. File blah blah blah. Line two model from PFT import Lara config blah blah blah. Cannot import prepare model for int a training. Maybe it's used now, and that is why it's not being used here. It's not being used here. I will look for that. PFT. When I run the fine tuning sample code from llama recipes, I get this error. My code is this. Has this method have been deprecated or does my version does match? Thanks for the reply. Yes, has been deprecated for quite some time. Okay, probably I take this from a previous old version. It has removed. Please use instead. Okay, thank you. Maybe that's why it wasn't used. Uh, okay. Um, let's return to the code because yes, this is here, but it's not used. Okay, that's great. The one thing it's done, it's resize token embeddings, length of the tokenizer. Maybe we should do this. Forget about this and do this. Oh, but there, then it's not token yet. It's after the model and the tokenizer it's created. Oh, but we have this base, and until that, this is called base. Okay. Yeah, just yeah. Okay. Let's try again. So I'm checking again. Local config get prepare. hmm, Okay, more errors. Sure. So traceback says transformers have utility. During handling of the above exception, another exception occur. Uh, Here phase error evaluation. Repo ID must use alphanumeric charts or these and these are forbidden. Okay, the problem I think it's yeah the one thing I was mentioning. we're passing a string, but this is not the one we have locally. Um, let's interact and let's discuss this with Copilot. I'm going to copy this. Oh, sorry. I'm going to create a new session and I'm going to say, hey, I'm trying to fine tune using PEFT slash Laura technique a model I had in Llama, which is 31B. Take a look at code and tell me what you think is wrong. Oh no, how can I do that? And I'm going to remove this. Okay, no. Okay, perfect. Let's ask Gemini Pro. Uh, yeah, I know that. Oh, what happened? Um, so one thing we can do because of the time, also I am checking that, it's that we can, since I mean I will be streaming two of this today, we can take a little bit more time of this session for the next one. I mean, and then compensate later for racks. I think this is worth doing also. So if you agree, let me know in the comments. If you disagree, also let me know. If nothing happens or anyone says something to the comments, I'll probably be taking that time. And I will explain that in the beginning for the next session. Don't worry. So let's see. Fine tuning model, llama like, blah blah blah, involves a few steps. First, you need to ensure the model is in format compatible with having phase transformer, as PFT works in this library. Okay, llama models might need to be exported, or you might need to find an equivalent hidden phase model identifier for your geometry 1B model. I can create a Python script for you that outlines the process of fine-tuning hem-like model using PFT LoRa. This script will include the loading from the model from and tokenizer. You will need to specify the correct phase IT model. Okay, setting up LoRa config, preparing. Okay, let's then dig if there is one model for that in Hugging Face Hammer 3 1B. Okay, I think it is. This repository is publicly accessible, but you have access contributions to access file. Okay. Oh, to access Hammer Face, you're required to review and agree to Google's usage license. To do this, please ensure to log into Face. Okay. Um, output usage pipelines. Not Okay, yeah, this is the one. I think this is the one. Uh, if okay, let's keep. If there is a Hugging Face model and I train it, can I use it locally? The answer, I suppose, is yes, because for these slides I created and the thing I investigate, it's that once we fine tune the script, we could import in the LoRa output actually the code it's supposed to do that and save the model in a folder called the LoRa output, something like that. But I just want to make sure how does that work. Um, I saving the model in a local folder or what? That's a great question. Yes, absolutely. When you fine tune a Hugging Face model, even if you start with the model from the Hugging Face hub, the fine tune version or LoRa app that was saved in your local machine, you can then load and use this local version without needing to reload it. Only that you're loading the base model for the first time. Stepping locally in the trained arguments. Okay, yeah, this is what's happening now, right? Trained arguments, the output here. Yeah, exactly. Perfect. Yeah, I think we can agree then now. So let's do that. Oh, come on. This was. So the name of it, it's Google Hema 1 billion, right? Huh. Yeah. Okay, let's do that. Let's test this. And let's see if it works. Okay, you cannot access that repo. It's restrict you have access and be out of the case. Please log in. Okay, perfect. Let's keep with this. I'm actually liking it. Yes, absolutely. When you fine tune a Hugging Face model, okay, um, I'll create a new Python script in this directory. This script, okay, fine tune. Let's see the difference. Install necessary libraries, okay. No, no worries. I don't like to keep this undo. Um, yeah, no need for that. Thank you. Important consideration, model compatibility, dependencies, script. Okay, now we can add this. Well, I'm going to change the name to train to fine tune uh, model. Perfect. So here I'll say, okay, then take a look to the code in my file and tell me what you think. Does it fulfills my intentions? Oh yeah, I see. It's in the edit one. Um, okay, let's see the output. Okay, I read that script. It's a good starting point for tuning a HAMA model with LoRa. Here's what I see. Model and tokenizing loading. You're correctly downloading the model and its tokenizer using load import with true and device of the map. It's good to manage the resource. Token embeddings. It's generally harmless, but usually only needed if you added new tokens to tokenizer. Okay, configuration. You set the target models QProj and VProj are valid, but for HEMA models, it is common target more models, potentially better results. Okay, thanks for that. I'll keep these changes, and let's see these also. The suggestion I like actually. PFT model, it's used correctly to apply the LoRa configuration. Saving, okay, things to consider for filling your intentions. Fulfilling, okay, I write it wrong. The prepare model for KB training, the line based prepare model, it's comment out when using quantization like this. You should implement this and call it for applying. Okay, this prepares the quantized model for an efficient training, data science and training. These sections for loading your data set, load data set to and actually training are comment out. Okay, yeah, no worries. I comment that on purpose. The models optional. I'll make on comment. The script looks like a good start. hmm Prepared model. Okay, okay, yeah. Um, so this says it's good to KK Proj, also or Proj, Gate Proj, Up Proj. It's common to target more models. Well, for the moment, I'm not sure. Okay, I will keep it as it is. Since I not fully understand what's happening there, so I will try to research a little more. But for the moment, let's keep it that way. And here, uh, help us with this. The author you're encountering means that it's a gated model interface. It requires things accept the model terms. I need to code this. I'm not sure you can. Cognitive Face CLI. I need to install that. So okay, let's do one thing, and we're almost in time for the next session, and I need to do some things like post announcements and stuff. So we will pause this at the moment. We will return with the rack session. We will explain racks, and we are going to resume this in the rack session. Right? Does that make sense? Or maybe we need to finish this in order to start the rack because I think that's important. Um, I don't know. Um, well, it will depend on to you because I know a lot of you want to see the rack function. Maybe when we finish that, because that's not kind of how to say that complicated, we can return to this, right? So stay tuned. Um, Next session will be starting in 15 minutes. So thanks so much for joining. Again, repo is containing everything. I'll be updating the repo some days after this if I manage to fine tune this. Of course, I'll not be loading the full model because that will be a lot of information to host, but then you can reproduce in your own computers. All right. Thank you so much. I had a lot of fun. I hope you do as well. And I will see you in a couple of minutes for the next section, where we are going to implement retrieve augmentation generation. Right. Um, Thank you. I'll see you in a couple of minutes. Bye.